When taking students on extracurricular road trips, the school typically pays $450 to rent a bus using Regal Charter Service. However, the school secretary decides to call up a competitor to see if the rates are better. Here's what the representative from Fly By Night Bus Rentals has to say. Okay, so for the record, Regal is what they normally do. The school secretary called Fly By Night. Okay? Here's what here's what Fly By Night has to say. Regal charges a flat fee, but think about the cost per student. With Regal, if only 4 students go on the trip, that's $450 divided by 4, which is $112.50 per student. In this case, Fly By Night would only charge, what is that? $78 per student? Wow, that seems crazy, doesn't it? Think of the savings. But what about large groups? With 54 students, you'd still be paying $450 divided by 54, which is $33 cents per student. With Regal, with us, 54 students is only $3 per student. Can you believe it? I know. It's all because we use a linear model to determine the price per student. It just makes sense. Of course, you have to take between 4 and 54 students on the trip, but that's no big deal. So can we count on your business? So what do you think?
Seems legit.
Seems legit, okay?
So, watch one of those videos
yeah, an infomercial? Yeah, sorry about that. Sometimes I get a little too into reading the problem. So, determine the function rule that could be used to compute the cost per student with each company, and then fill in the missing entries in each table. Okay? So, what formula, what equation do you think that each company is using? They did give you enough in the problems for you to know. What do you think?
One is linear, as it says.
One's linear, as it says. Which one is that?
The right one,
The Fly By Night? Okay. So Fly By Night uses a linear model. So how are we going to come up with that model? What's the equation for that one?
Well, we find out this.
Whoa, purple doesn't work. Y equals? How are you going to figure that out? There's like 84 ways to figure this out. Maybe not quite 84, but at least 3 that I can think of off the top of my head.
Close to 84.
We can find M with the points.
Yeah.
So how are we going to do that? How do you want to do it? I'm going to let you choose today. So M is change in Y's over change in X's, right? If we're doing this, what's the change in Y's? 78 minus 3? 75. What's 4 minus 4 minus 54?
50.
Negative 50.
It's 1.5.
So 75 divided by negative 50 is negative 1.5. That's the slope. How do we find the y-intercept? Isn't it just 78? Oh, no, it's not?
No, because that's 4.
Oh, that's 4. What do we need? 0. Okay. So how do we figure it out? First of all, tell me this. Is it going to be higher than 78 or lower than 78?
Lower.
And if it's...
Oh, higher, yeah.
Yeah, higher, right? Because it's decreasing. Okay, so this is going to be higher going up this way. So it's at 4. Would it be really a big deal to count back to 3, to 2, to 1, to 0? Isn't that a possible way? Excuse me. So a change of 1.5, a negative 1.5, a change would be easier to go to 2, wouldn't it? 1.5, from 3 to 2, that's a change of 3, isn't it? What's this plus 3? 81. And then from 2 to 0, isn't that another change of 3? What would that be? Plus 84. So that really took a lot of thought, but that was the actual math, right? So what's another way that we could do this?
Well, we could really plug in the coins. But,
Can't you do a list and spreadsheet? Right? This I want to be X. And this I want to be Y. And I want this to be a 4. I want this to be a 54. And this, I want, oh, you can't see that, I'm sorry. Let me zoom in, I'll zoom back out in a second. So I put an X and a Y, X here, Y here, a 4 here, 54 here, and then I have a 78 in the first with the 4, and then I have a 3 with the 54. And I want to add a page that is a data and statistics, right? I want this to be, oh, I want this to be X, and I want this to be Y, no, Y. I want to analyze my plot, my points, and find what kind of regression. Linear. There's 2 linears. Which one am I trying to find? MX plus B. Oh, look at that. That's exactly what we got.
Yay.
Negative 1.5x plus 84. So when I go to my graph page, which I will maybe do, okay, graph page, I can go ahead and put in y equals negative 1.5x plus 84. I broke it. It's broken. Oh, it's not broken? What's wrong? Oh, the window. I'm just repeating what I hear a lot. When people first initially graph something and then they can't see it, they automatically assume they broke it. I know that's what you do. That's why I said it. Okay, I want you to think of a different way instead of automatically just assuming you broke it. What does my X max need to be? Look on my tables. What kind of X max do I need to be able to look at?
65.
Maybe 65?
Maybe.
I'm okay with 65. Our X values, right, the ones that were given. We can go back and change it later if we need to. Y min, maybe negative 1. Why am I only going to negative 1? Why am I not going to like negative 10 or negative 20?
They're not negative values.
Okay, so this, a negative X would imply that there's negative students. Now, there are days that I feel like I have negative students, but we're not going to go there. And then the Y value would be the cost. So the company's going to pay us? No, that doesn't make any sense, does it? Okay. What kind of Y value do I need to go to for the biggest value? Looking at both tables.
84.
Looking at both tables.
120.
So maybe 120? Okay. That's a pretty good picture of that one, isn't it? Okay. So I'll put the calculator aside for a moment. Let me zoom back out. Let's go and, can we go and fill in this table real quick? If I kept my calculator out, we could just press Control T, couldn't we? Or we could plug each one of these values into that equation. Neither way is hard, is it? Okay. So let's see if I can find 15, 61.5. Somebody have 30 yet?
39.
39. I'm going to check. I'm going to check your math. Oh, look at that. 30. Good. That was good math. That was very good math. 45. What do you say it is?
16.5.
Oh, look at that. I even checked it right there with my calculator, 16.5.
Do we need to put like $16.50?
No. I just happened to because this one already had the dollar sign and this one already had a dollar sign. But because the column is called cost per student, the dollar sign is not actually required to be there. Okay? I'm just kind of keeping it in context so I keep it in my brain. Okay? All right. What about the other one? We got to do Regal.
That's rational.
So why would you say that?
Because there's already equation up there. Text that explains.
So you think it's a rational function because every time the person, this crazy woman or I assume it's a woman. I shouldn't have. That's very sexist to me. I apologize. Could be a crazy man. There's definitely plenty of those. Okay. Every time this person on the phone talks about how to get the price of Regal, it says 450 divided by 4. 450 divided by 54. So what do you think the equation is going to be?
450 divided by X.
Y equals 450 divided by X. Very good. So I don't even need to go about getting some sort of random equation, do I? Like with stats and data and statistics and stuff like that. Now I can just go Control T. Let me get rid of the table real quick. From here, I can just go straight to my tab. And I can put in, I like to use this button so it automatically is a fraction. 450 divided by X, because then it looks like I need it to look. You guys know I'm a very visual learner, right? Okay. So now when I press enter, did I give myself a good window to begin with?
Yes.
Yeah, I really did, didn't I? Okay. So I'm going to press Control T so that I can get my table. Let's get this over so you can see. So 15.
30.
Oh, I'm in the wrong column. 30. What do you think some people's reaction is going to be when it goes from 112 to 30? Is that huge? Is that a huge jump? Okay, so check. Did we do anything wrong? I'm going to add a page that's a calculator. 450 divided by 15. Isn't that 30? Oh, you can't see that at all. 450 divided by, 450 divided by 15 is 30. I didn't do anything wrong. I'm just reading the table correctly. So 450 divided by 30 is going to be what? 15. And what about 45? Yeah. Hopefully we could have done most of those in our head, right? Okay. Don't forget that you do have your brain most of the time to use. Some of you forget it some days, I'm afraid. Sketch the graphs of these relationships on the grid to the left and check using your graphing calculator. Well, I guess we did it a little bit out of order where you're using the graphing calculator already to get our tables and to use our math. So we already kind of have a picture of what it looks like. Okay? But if we're randomly graphing this, how do I graph 450 over x? Probably plot the points, right? Plot the points. So 412 ish, 1530, 3015, 4512, and 54:8. Oh. So something like that ish. So that's regal, right? That's 450 over x. I'm going to use a different color. I'm going to use pink to graph this one up here. Okay. So 478 ish. 1561.5, 30, 39, so right under 40, 45, right there, 16.5, there-ish, and 54 would be 3. Like that. What do you think? Is that pretty good? It's pretty close to the calculator, isn't it? Okay. Treat these equations like a system and solve it. When we are solving a system of equations, what are we looking for? The points of intersection. Here, by looking at this graph, it would be an absolute pure guess, wouldn't it? But what could I do instead? Oh, I could use the calculator. Okay. Menu, analyze. I want to find the points of intersection. So I want this one first. That first point is what? 675. Menu, analyze, intersection. The second point is 50 and 9. Okay. Okay, that's all fine and good, but that's not what it asks for. It says, what do the solutions tell you about when fly-by-night is a better deal? What do these points mean in this problem situation? When? The pink is higher, right?
Yeah.
The pink would be more cost. So the blue, the rational function, Regal,
It's lower.
It's a lower price.
Between 6 and 50.
So if you take what?
More than 6 to less than 50 students.
Between 6 and 50 students, then what's true? From here to here, Regal is cheaper. Is fly-by-night ever cheaper? If you take
No.
If it's more than, if it's less than 6 or more than 50.
Yeah. But it can just be 4.
oh, if it's less than 6 and more than 50, right?
Yeah.
But it says that the company can just take between 4 and 50.
You can take only between 4 and 54. So 4 and 5 is cheaper. What else is cheaper? 51, 52, 53, and 54. If you take that many students, then fly-by-night is cheaper. This should be a sentence. If you take that many students, I guess like or right there, comma, period. So fly-by-night is not really that great at math. It's not the better deal, is it? Okay. Questions? We good? All right. One of my favorite worksheets to do all year. The parachutist called from her cell phone. Hey, Walter, you'll never guess where I am. I'm parachuting down over your neighborhood. Even though I'm descending at a constant rate of 4.8 feet per second, I'm afraid my landing will be a little bit rough. So do me a favor. Go outside and get on your roof. When you see me pass overhead, toss me a pillow. What? Okay, first of all, here's a problem I have. I'm going to zoom in so that we're very clear about this. Okay? Walter is as tall as his house. Look at him. If you stood him up beside his house, he's as tall as his house. So he's a giant to begin with. Okay? That's how he would have to be to throw it that high, right? It's a pillow. It's not a brick. I mean, I hope it's not a pillow with a brick in it, right? Have you ever tried to throw a pillow? I mean, it depends on what kind of pillow it is, right? Like a heavy pillow or a down pillow. Those are different to throw, okay?
It's a Tempur-Pedic pillow.
So, Tempur-Pedic, yeah, you could probably throw it pretty far, okay? Also, if it is a pillow of bricks, you could probably throw it very far, especially Walter since he's as tall as his house. Okay? Just a little fun with the drawing, that's all.
I don't know what he made fun of the fact that she's calling him on his cell phone.
Oh, yeah.
While parachuting.
Oh, yeah. Yeah.
Use his cell phone.
I've never been parachuting, but it's on my list of stuff to do before I die. So I'll let you guys know how that goes.
Just call me.
If I can call somebody when I'm parachuting.
I'll
Okay?
throw you a pillow.
So when Walter saw her, the parachutist was 40.6 feet above the ground. Walter threw the pillow with an initial upward velocity of 40 feet per second so that its height could be found with this function. where X is the time in seconds since the pillow is released. The parachutist missed the pillow as it went up, but caught it on its way down. Wow.
So logic, just logic, yeah.
She obviously does not play softball because she can't catch. Well, what linear function can be used to find the parachutist's height in terms of X, which in this case is the number of seconds since Walter threw the pillow? Where do you think we're going to get that? Is there enough information given to us to know that? Okay. Well, what would her y-intercept be? What would the y-intercept be in this case? Where'd she start?
40.
Yeah, it says right here, right? 40.6 feet above the ground. So we've got our y equals 40.6 feet above the ground. And what is our slope? What's our rate of change?
4.8.
Why? Okay, first of all, why would you say 4.8? And then why? Second of all, why would you say negative 4.8?
Because the draft is going down.
Okay, so she's falling,
She's losing
right? She's
altitude.
losing altitude, so we know it's a negative number.
At 4.8 feet per second, it says in the instructions.
Yeah, she told us that. Somehow she knew that. Maybe she's looking at her something-ometer that they have as parachutists. Okay? 4.8.
So
Hurry up.
it would just be 40.6 minus, right?
Yeah, we could write 40.6 minus. Yeah, absolutely. That's fine. So 4.8x, right? That's our rate of change, so we've got to have that x.
That's now your fault. I'm not going to get rid of this.
Treat these two functions as a system and solve it. Treat it as a system and solve it. What do the intersection points mean in the context of the problem?
Oh my God. That's like words you can talk to.
Well, first of all, how are we going to solve it?
We set them equal.
Set them equal to each other. So negative 16x squared plus 40x plus 15 equals 40.6, and I'm going to put minus 4.8 because that's what you guys wanted me to put first, and I already put a plus. You okay with that? Okay. What kind of equation is this now? It's quadratic, so I need to get it
Wait, it's
equal to 0. What's right?
is this picture going to be what the graph looks like?
Possibly. Possibly. Okay? That picture was to kind of help you figure out that this parachutist is falling. She's not rising from the earth, because that would be a whole nother issue. Maybe aliens instead of just parachutists, right? Okay. So, subtracting 40.6 on both sides and adding 4.8x on both sides gives us what? Negative 16x squared plus 44.8x minus, what was that, 30 to 25.6? Is this correct? You guys are checking my math, right?
What do you mean?
40.6. It is correct?
Yeah.
You fixed it? Okay. So now what?
Quadratic formula.
Oh, quadratic formula? Okay. X equals negative b plus 10 minus the square b squared is over c over 2a. I'm going to let my calculator do. I don't know what my calculator's doing. It's freaking out. Menu.
No, it's broken.
It's broken. I just have to give up now, right? Okay. And add a calculator page. I'm going to let my calculator do all my arithmetic for me. I'm just going to be real careful. Okay? Negative 44.8 plus. I'm just going to do the plus right now. The square root of 44.8 squared minus 4 times negative 16 times negative 25.6 all over 2 times negative 16. X equals 0.8. I'm going to go get the same thing I just entered, and I'm just going to change the plus sign to a minus 2. Is that the solution to my system? No, those are my x values, right? Those are my x values. So how do I find my y values? One of the formulas. Doesn't it have to work for both formulas? Doesn't it have to give the same y value for each formula? Just checking. That was an issue on a worksheet we did a couple nights ago. Anyways, we'll talk about that probably tomorrow or the next day. So 40.6 minus 4.8 times 0.8. Well, I can't even read that. So 0.8 is 36.76. Or 2. 31. What does that mean? Those are the 2 points of intersection, right? So what does that mean? Look back up here. Isn't that this point right here and this point right here? So she has 2 chances to catch it. What happened at this point? She missed. She missed. With a frowning face. What happened at this point right here? She caught it. But what does this point mean? We know this is where we caught it. When did she catch it? 2. What's the x value represent? What's the x value represent? The number of seconds since Walter threw the pillow. So 2 seconds after he threw the pillow, she was 31 feet above the ground. Right? When she missed it, it was 0.8 seconds after Walter threw the pillow, and she was 36.76 feet above the ground. Does that make sense to you? It does not? Oh, it does. Okay.
Math does the problem.
Understood. Understood. Okay? You have 2 problems to do for homework tonight. You have these 2 problems to do. Okay? So, as I've tried to do, not very well on this problem, because I should have said she missed the pillow 8 seconds after Walter threw it when she was 36.7 feet above the ground. Seconds, what did I say?
You said 8 seconds.
Thank you, 0.8 seconds. And then when she was at 2 seconds after Walter threw the pillow, when she was 31 feet above the ground, she caught it. Those should be real complete sentences, okay? That's what I want on 3 and 4. All right? Find an answer and then write me a sentence about what it actually means. I mean, like an actual sentence. Capital letters, correct punctuation, stuff like that. Okay? That's what I want you to do on 3 and 4. Any questions?
Say it's Ruth Knight.
Are we doing
Any questions?
Ruth Knight said.
Miss Dan?
It's her birthday.